So for this video, I'm going to do a little bit of a challenge. And I think this might be a new series for the channel. And I'm actually really excited because this is actually, I don't know, it's just really exciting for me. The fact that I get to do a series now and it's based on integration. I'm actually really enjoying integration, and you know, your boy might even be able to join like integration bees, but I'm still learning, by the way, just a fun fact. But in this video, it's going to be a little bit different. Now what we have over here is the question. Now the question says, evaluate the following without the use of a substitution technique. Like we basically can't even use like any use substitution. We can't use any we can't use integration by parts. We can't use trig substitution. We can't use any type of substitution. We have to just integrate without any substitution. Now that just makes this question a lot more challenging, because I feel like this would have been like a 3-minute video where I just immediately find the answer, or maybe a 4-minute video, because it's a definite integral, by the way. Okay, so let's do this together. Okay. Now, first of all, what we need to do is let's look at the integral, right? It's the integral where the lower limit is natural log of 1 and the upper limit is natural log of 2. Now, over here, the integrand is x cubed over x squared plus 1 with respect to x. Okay. Now, how are we going to do this without substitution? This is going to require a lot of math skills, and I'm going to show you why. Okay. So first of all, let's get with the integral. Okay, so we have the natural log of 2. Let me just say ln 2. And what is the natural log of 1? Well, we know that the natural log of 1 is just equal to 0. So we don't have to write natural log of 1 all the time. That was just something I just added here. So that's just going to be 0 to natural log of 2. Natural log of 2 is an irrational number, so we're going to keep it like that. We don't want to approximate now already. Okay. Now, first of all, how are we going to do this without the substitution? Well, here's a way. We have to break it up. And I'll show you how to do this. So, we are really concerned about the fact that we have two terms over here, right? We have a binomial in the denominator. So we can't really, if we had like a binomial in the numerator, it would have been easier. Then we could have just broken up everything, right? But no, we have a binomial in the denominator. Now watch this, right? X cubed over here divided by, and then we are going to have, let's just write this a little bit higher, so we're going to have x cubed divided by, so we still have x squared plus 1, but what I'm going to do is I'm going to try and break up this fraction. Now how can we do that? We just need to add more terms to the top. Now how do we add more terms without ruining this entire expression? We need to keep the expression the same. Well, just pay attention over here. If I say plus x minus x, do you note how if I were to just simplify the expression, this would cancel? So that's why it's perfect. We keep this in. And I'll show you what we are going to do from here. We are going to have this equal to the integral of natural log 2 and 0 over here. And then we're going to have the following, right? What can we do? Well, we can see that we have this denominator. We can treat it as one term, right? As a bracket, rather. And then we can actually break this up. So we can say this is x cubed plus x, which is a single bracket. And then this x can also be its own bracket. Meaning, if we're going to use the following form, we're going to say a plus, let's say a plus minus b divided by c. This can also just give us a over c plus minus b over c. Meaning that this is our a, this is our b, and this is our c. So let's just do exactly that. So we're going to have x cubed plus x divided by x squared plus 1. And then we're going to have minus x divided by x squared plus 1. Note how we kept the denominator the same throughout these two terms. And then because it's just two terms in the integrand, we're just going to put a bracket here, and then it's with respect to x. So I should have done it here. Okay. Now that we've done that, what else can we see? What else can we see over here? We have the natural log of 2 here, and we have 0. And then over here, we can actually take out x as a common factor. So meaning that if we take out x as a common factor, well, let me just draw my bracket here. X will go into x squared plus 1. And then the denominator is x squared plus 1. Ooh, what do we have here? Let me just finish writing this whole line here. We're going to have x over x squared plus 1 with respect to x. Now what we note over here is that these can cancel now. And that's great, because initially we wanted to break up this fraction, which is exactly what we just did. And therefore we are left with x over 1. So this is the integral from 0 to natural log of 2. And then we're going to have the bracket, and we're going to have x on its own, because x over 1 is just equal to x. And this is minus. And then I'm going to take the x out over here, such that I can write it as x multiplied by 1 divided by x squared plus 1 with respect to x. Okay, here we are. So now that we are over here, what do we note? We have x as a common factor as well. Okay, so this is what we don't have to take out x as a common factor. This is why, because over here we can actually just take the integral into these two terms, because what do you note? This is a term and this is also a term. It's separated by the subtraction sign. So therefore, we can take the integral into the x and the integral into that. So therefore, it will be the integral of natural log of 2 and 0 of x with respect to x minus the integral from 0 to natural log of 2. And then we're going to have, you know what I'm going to do right now? Because I thought I was going to take out the x as a common factor. I apologize about that. I'm going to put it back into this bracket here. So it's going to be written as x divided by x squared plus 1 with respect to x. Okay, now we've gotten to this point. It looks crazy. Now, let's just take into consideration the following idea, okay? You would probably go ahead and use U substitution immediately, or T substitution or whatever. And remember, the question said without the use of a substitution technique, meaning we have to use our own brains to actually determine this value of the integral. So we know we can immediately do this integral. But what about this one? How do we do this without the use of a substitution technique? Now I'm just gonna take this integrand over here and then pull it down, and then we're gonna look at it carefully. Okay. So what do we note about this? This is the antiderivative. Now we're going back to derivatives. The integral is just the antiderivative, right? Meaning that if I were to take the antiderivative, I would just get the derivative of this answer here. So I want to break this stuff up over here, okay? So what I have over here is, I'm going to say d by dx of, and then what else, what can we say over here, right? We want to get towards this answer by using derivatives, right? So how can we get close to that? Now let's just realize something, right? We know that the derivative of the natural log of x is just equal to 1 divided by the inside of the bracket x multiplied by the derivative of the inside of the bracket, which is 1. So therefore we don't have to write that 1. So it's actually 1 over x. And therefore this implies to us that the integral of 1 over x is, with respect to x, is just going to be equal to the natural log of absolute value of x plus c. Okay. Now why am I going into this detail? Now what does this actually imply to us? Remember, this derivative, let's just say that this implies to us that the derivative of the natural log of this, which is x squared plus 1, is just going to be equal to 1 over x squared, 1 over the inside of the bracket, which is x squared plus 1, multiplied by the derivative of the inside of the bracket. The derivative of x squared is just 2x, and the derivative of 1 is just 0 because it's a constant. So that's basically what we have. And now what I want to do is the following. I'm just going to evaluate this here, or simplified. We're going to have 2x divided by x squared plus 1. Well, let me just keep the 2 out for now. We're going to multiply this by 2, and it's still the same thing. We're getting so close. Look at this. We have 2 multiplied by exactly what's in this integrand over here. Now, what are we going to do? Because we still have this 2 in the way. Now, how are we going to get rid of this 2? Well, obviously, we need to multiply by a half. So what we are going to do, we know that this is equal to that, right? So what we are going to do is so I'm just going to try and isolate this over here. We're going to say that the derivative of half, remember we need to halve the 2 in order to get 1, right? We want to get rid of the 2. So it's a half multiplied by the natural log of x squared plus 1. And this is just going to be equal to, we know that this over here is equal to that. So we're just going to write this, we're going to take this constant out. This is going to be multiplied by 2 into x over x squared plus 1. And then therefore these can cancel. And can you see how this gives us x over x squared plus 1? Which is exactly the same answer, or exactly the integrand that we have over here, that we want to take the integral of. So meaning the integral of this integrand, x over x squared plus 1, which we just determined, is equal to a half times the natural log of x squared plus 1. Isn't that great? Plus c, obviously, because it's the integral. So let me just write that down for you if you didn't get that. We are saying that therefore the integral of a half, we are saying that therefore the integral of x over x squared plus 1 with respect to x is just going to be equal to whatever the derivative of that was. Remember, because this is the antiderivative. Therefore, it's going to be equal to a half natural log of absolute value of x squared plus 1 plus c. Okay, so that's exactly what we're going to be writing down. So that is just replaced with this over here. Okay, great. So I'm going to rewrite everything again, but now with the information that we have. So remember initially that we had to find the integral where it's from 0 to natural log 2 in the upper and the lower and upper limits respectively of x with respect to x minus the integral of x over x squared plus 1 with respect to x. And then we had natural log of 2 and 0. Note how these are not changing because remember we're still keeping the same variable. We have not substituted at all. And we know that, okay, we can integrate the first one. Let's start with this one here. This is going to be equal to, I'm actually going to use the notation that I was now taught. This is going to be, the antiderivative of x is just going to be equal to x to the power of 2 divided by 2. Evaluated at natural log of 2 and 0. So I'm going to do it like this. And then we're going to have minus the integral of all of this, right? We're basically just going to be doing this, right? The integral of this with respect to x is just going to give us this answer. But we're going to leave out the plus c because it's a definite integral. So it's just going to give us a half natural log of x squared plus 1. So it's a half natural log of x squared plus 1. And then this is evaluated at natural log of 2 and 0. Okay, now obviously my technique that I would use over here is going to be like this. The red is going to be the first term that's being evaluated, and then the blue is going to be the second term being evaluated. So let's do the red first. This is just going to be equal to the natural log of 2 all squared, because we're subbing in the upper limit first, divided by 2, and then we're going to minus it by when we are including the lower limit. So this is going to be 0 square over 2. And we know that this will cancel and give us 0. Okay, and then therefore this is just going to be equal to, I'm just going to write it here, this is going to be equal to, without this basically, it's going to be the natural log of 2 all squared over 2. Okay, so that's what it is now. That's the value of the red. Now let's deal with the blue. Okay, so the blue will be over here. That's not blue. The blue is going to be here. So we're basically going to have, we're going to exclude this negative because we're going to minus them at the end. So it's going to be a half multiplied by the natural log of the absolute value of what are we dealing with first? We're first dealing with the upper limit, so it's going to be the natural log of the natural log of 2. Why am I writing so small? The natural log of 2 all squared plus 1. And then we're going to have minus. We're going to use the lower limit now. It's going to be a half multiplied by the natural log of, it's going to be 0 squared plus 1. Okay, great. And then we can simplify more. So we're going to have a half multiplied by the natural log of, we're going to leave it the same, it's the natural log square, the natural log of 2 squared plus 1. And then it's going to be minus. Now we can just write this as a half multiplied by the natural log of, well, I mean, this is going to be 0 plus 1, which is 1. And we know the natural log of 1 is just equal to 0, so therefore this whole entire thing is just equal to 0. So therefore the blue, we're just going to be left with a half multiplied by the natural log of absolute value of natural log of 2 all squared plus 1. Okay, now remember the question said we're minusing them. So therefore we're going to minus the red by the blue respectively. So therefore we are going to have the black, we're going to continue with the black now. Okay, so I'm going to do this. Okay, so the red was the natural log of 2 all squared divided by 2 minus a half multiplied by the natural log of, we're going to have natural log of 2 all squared plus 1, and there we go. And then can you see how we only have values over here? And this should actually be our final answer. Now if you want, you can approximate the value, and the approximate value would go as follows. So if you put it in a calculator, you'll get an approximate value of 0,15. Let's say 1504. Okay, and that is the answer to this question.